first thing we saw was physical quantities. Can anybody tell me what is your understanding on physical quantities? Charles, if I ask you what is physical quantities, what would you say?
I would say like something like a measure of some kind, like maybe a, I don't know how to describe it. I know what it is, like, I don't know how to describe it, but like a physical quantity of something, like you have like 12 liters of water, or like, 15 milligrams of some dose of medicine.
Excellent, yeah. Something that we can measure is a quantity, okay? It's a quantity that we can measure, and it is important for us, right? There are some base quantities. What are those base quantities? Something that we measured during the experiments. We've done a lot of experiments already, right? What is that you measured?
Length.
Huh?
Length.
Length, right? Length is a base quantity. It's not a derived quantity. Derived quantity would be a combination of base quantities. If you see units, by the units you can say if it's a base quantity or if it's a derived quantity, right? What is another base quantity? You have length. What else you measure? Huh?
Speed.
Speed. Is speed a base quantity or a derived quantity?
Derived.
Derived, right? Why? What is the combination of what?
Rate.
Length,
Mass.
and what is the other one? Time. Time is a base quantity, right? It's just seconds. Length is liters, right? The unit is something, but speed was a combination of that, right? Combination of length and time. So that's the difference between base quantity and derived quantity, okay? Another example of mass is also a base quantity. Electric current, amount of a substance, like mole, right? It's also base. Now, derived could be area, right? Derived area, 2 lengths, right? It's m squared. Volume is another derived. Those are examples, okay? Now, when I ask you on the quiz to differentiate between scalar and vector, what is a vector?
Direction and magnitude.
Is what?
Direction and magnitude.
Direction and magnitude. Of what?
A line.
Quantity.
Quantity. You have to say it's a quantity, right? That requires direction and magnitude, okay? What about scalar? It's just magnitude, right? It's a quantity that just, it's enough. The way, if the mass of a body is a scalar because it doesn't require direction. Velocity, yeah, requires direction, so we need to use a vector to represent that. Because when I say I'm at 60 miles per hour, that's just my speed. It doesn't say where I'm going to. I could be going to San Diego, or I could be going to Sacramento, okay? But if I assign a direction, then I can describe my motion better, right? Is that, okay, so you cannot define, that question is on the final, you cannot define saying, well, a scalar is a vector without direction, right? Because you trying to explain with the other one. They are both quantities. One requires direction and the other doesn't. Okay? Okay. Another thing is we need to measure. We have to measure the physical quantity that we can measure. Think about that also, okay? Something that we measure. We measure the time, we measure the length. Those are two different quantities, and then we calculated the speed, and that's another quantity, and is a derived quantity. What's the calculation between two measured things? All right? So another thing we talk about in physics, sometimes we need to simplify things, right? The car, for instance, we can represent the car as a dog to make things easier, to make our calculations, okay? So this is a way that physicists use to model motion. The other thing we discussed about was about the fact that motion is relative. Okay? When we say something is moving, it has to be relative to, we have to ask, is relative to what, right? Am I moving right now? No, right? So if I move, do you see me moving? Yes, right? And I see you moving, okay? So because you have this frame of the ground, right? You have this, frame of reference to the ground, you think I am the one moving, right? But if I don't know, if I have something just moving under my legs here, I'm not stepping up, so I'm going forward or backwards, I'm just moving like this, and I'm sleeping, and suddenly I wake up and I see you, I think you are the one moving. When you're inside the bus, just sitting there, you see all things moving, like buildings, trees, everything is moving, right? And if you just wake up at that moment, you wouldn't be able to say, who is moving? Can you imagine that? Do you understand what I mean? The frame of reference, when they say, what is the frame of reference? So let's talk a little bit about vector. So we know vector has to have a direction, so we're going to represent that graphically by an arrow. Right? This is the arrow, the vector, and sometimes we want to say the vector is coming out of the board, so we represent that way. Sometimes you want to say the vector is going inside, we're going to represent that way. All right? So when we say I have 60 miles, going at 60 kilometers per hour, for instance, and I say going east, that's my velocity, because I'm giving the direction. All right? What about acceleration? If I ask, what is acceleration? Can anybody try to explain to me?
An object moving faster.
Faster. Well, I can, let's think about that definition, okay? I'm moving right now. Am I moving at a constant speed?
Yeah.
Yes. What about now? I'm moving faster, but am I accelerating or not? I'm moving faster. Huh? But at constant speed. So that definition maybe is not good enough for acceleration.
Acceleration is moving at an increasing rate.
An increasing rate, right? That's increasing rate, right? So that's how you keep yourself fit all the time, you know. Okay. So, so the speed is, if the speed is the same, there's no acceleration. Is that correct? Okay, so let's think about this example now. I have here a road and my car is moving at a constant speed of 25 kilometers per hour. So that speed, the velocity is going up, right? And then at some point here, it's gonna curve and it's gonna keep the 25 kilometers per hour. What about that? What's happening here? Is this car being accelerated?
It's keeping the same rate.
Yeah, because it switched direction,
Huh?
changed direction, so I mean, it accelerated, right?
Yes. You have to separate the idea of speed with velocity, okay? So the velocity can have the same magnitude, but remember, velocity has direction. If something is changing, something is happening, right? It's being accelerated. If the direction is changing, but it maintains the magnitude, it has to be accelerated in order to curve like that. Okay? It's kind of unfair question because we didn't cover circular motion. Once we cover that, we will see that it has to be a force here to make this move, right? To go on a curve, you need a force, so that means it's being accelerated. Okay, I just want to bring this up right now so you are aware. So I'd like to do a little experiment now, and I need one volunteer to come here to read. No, but only it's too far away for you to read. And I just want a student to come here and confirm, and you have to trust him. Do you trust him? Oh, yes. So I have here 100 grams, okay? So I'm going to put this right here. So you do the reading. What do you read there?
Slightly past 1.0,
But that,
almost on it.
yeah, this is a different scale, but in this scale now, because this is 100 grams, we can say that this is 100 grams. Is that okay?
Yeah.
All right. So that's expected, right? To have. Now, let's try this one and see what this one is going to read.
The same 100 grams.
The same 100 grams. So now, if you hold it like this, and I put this here, what do you think is going to happen?
It'll pull evenly on both plates.
And what is going to be the reading in each one of these things?
Should be 50-50.
50-50?
Yeah.
You think it's going to split?
Mhm.
Anybody think differently? What do you think? You seem amazed. You're behind you. What do you think?
it should read 100 on both.
It's going to be 100 on each one of those. So there are two possibilities. One is that it's going to be 100 here, and the other one is going to be 50 and 50. Who thinks it's 50-50? Raise your hand. 1, 2, 3, 4, 5. Okay. Maybe 40% of the class. Who thinks it's going to be 100? So the class is divided, almost like 50-50, right? This is no election or anything. It's just it's just physics. So put them under that together. No, closer together, like this. Yeah. And facing to you because you're the one that's going to read. They're going to trust you. A little closer.
Much.
What do you think? No, it's because it's moving. Let me
Yeah.
just hold it.
Yeah, so it's at 50-50.
50-50, okay? Is that good?
Hmm?
All right, now start open your arms like this. More. What's happening?
No, it stays the same.
Same? Bring it back. What happened? This thing went up,
Yeah,
right?
it moves up and down. But for
Okay,
the most part, it stays the same.
Yeah, open.
So,
This thing is lying to me, come on. Again, good.
same.
Well, sometimes experiments don't work, you know. Maybe I need a heavier thing to make this thing, this is not very accurate. But the truth is, if it goes this way, what do you think it should happen?
Maybe pulling more weight.
The
Yeah.
more tension on the thing, you'll
More
get
than,
hydraulic
look,
leakage.
it's going now, you see? I see one here. Move. Yeah, and one there. Okay, thank you. Now, what is this showing? It's showing that, we need something other than just adding a magnitude, right? When it's lined up that way, when it's lined up this way, right? I have here weight of 100 grams, and then this and this was 50. So that means I can, this is a vector, I can add this up to here, so it's balanced out. 100 up, 100 down, right? Now what happens when I change this now, and this color would work here, right? Because I just add up, scholar would work here perfectly, but here would not work. Because I have a reading of 100 here, and here 100, and here 100, so that doesn't add up. So I need to use the projection of this one here, that's gonna be 50, okay? And the projection of this one here, that's gonna be 50, then I can have this in equilibrium. Is this example helping to understand why we need to use vectors? Okay. And if this adds up, right? It adds up, it cancels out. This one with this one is going to cancel out. Now, if I bring this guy down here and shift this guy down here, they will close the loop and will cancel out. If I add this with these two, will be 0. Okay? The same way, if I add this one with these two, it's going to be 0. Okay? Now comes the how to add vectors, right? I have two vectors. I have a vector A and a vector B. How can I add that? Well, I can use, there are different rules. One is the parallelogram rule, that I bring this guy down here, exactly the same, A. Then B, I bring it here, I build a parallelogram, and then A here, and this is the sum, this is C, okay? That's one way to do it. The other way is I bring A, it is called head to tail, right? I bring the tail of A and add up to B. This is B. This is A. And then I connect this one. This is the resultant vector. So this way I have my addition, right? This one is C. That is A plus B. So one method, a second method, And there is a third method that uses the projections, right? How do we calculate the projections of the vectors? On a coordinate system, if I have here vector A, and I know the angle, I can calculate the projection here is going to be AX. The projection at Y is going to be AY. Okay? And those are two vectors, right? If we use the concept of the unitary vector, the unit vector, that is modulo magnitude 1, so 1 times this quantity is going to be a vector in that direction. And this is going to be another vector in the other direction if I call this J. Okay? So AXI is one vector plus this other vector here, AYJ, is going to give me A. All right? And if I have a second vector, a vector B, let's say this one here, that I want to add, I calculate the projections of B on the x-axis. So I'm going to have BXI, and then BYJ, and that is B. If I want to add those, I just add these two guys, right? The x's and the y's, and then I'm going to have C. Is this okay? So if I give you the projections, you can calculate the angle. How can I calculate the angle? If I give you AX and AY. If I say this vector is at, this is 3, and then 2. And I can represent vectors like this, 3, 2, right? This is the point of the head here, of the vector. Point at 3, 2 on the coordinate system. This means it's a vector, okay? If I give you these 2 points, can you calculate the angle? What should I do to calculate the angle? Yes?
Can you use the inverse tangent?
The tangent, yes, the tangent. What is the tangent of this angle here? Tangent of theta is equal to what? Can you tell me the tangent? You don't know the tangent? How to calculate the sine? What is the sine of that?
Opposite over.
Okay, so let's review that again. Okay, let's review the trigonometric circle, because this is crucial. Otherwise, if you don't know this, you can't work with vectors. So the trigonometric circle, let's say this point here, I have an angle theta, and I ask, what is the sine of this, right? The sine. So I have a height here, and a distance here. Let's call this here A, and let's call this here B. So this is point A, B on the trigonometric circle, okay? And this here is my radius, okay? So the sine of theta, and this is not on my notes here, okay? Maybe you take a picture after I write all the formulas here. The sine of theta is the opposite side of the triangle, B divided by R, okay? The cosine of theta is going to be this projection here, A divided by R, okay? the tangent of theta is going to be the opposite side, b divided by a. Okay? So you see that the tangent of an angle is the sine divided by the cosine. All right? So this is the general formula for this. On a trigonometric circle, radius is 1. Okay? So actually, if you have this here as 1, if you measure this, this is the sine. If you make an angle of 30 here, and you measure this height, very as accurate as you can, you're going to see that that number is the same as the one that you get in your calculator. That's how they used to do when I was a kid. Okay? There were no calculators at that time. Or they had to go through tables because it was all tabulated. Okay? So, so now that I know this, right? And I say, if I give you AX and AY, and I ask you what is the angle of this vector, you can use this formula here. Okay? If I give you the magnitude of the vector and the projection on the x-axis, which formula are you going to use? Huh? If I give you the magnitude of the vector and I give you the projection, which formula are you going to use? This one, or this? Huh? The cosine. Then you can obtain your angle. Is that okay? So, let's see. Let me erase this a little bit. Get some space. So let's talk about the negative vector, right? Negative vector. If I have a vector A, and I subtract A, what's that going to be equal to? 0, right? But remember, subtraction is addition, right? Is addition. So if I can rewrite this like this, as the sum of A plus what? Negative A. Okay? And that is still 0. All right? So what does that mean? That means if I have a vector A going in this direction, I have the negative is going on the other direction like that, and it cancels out. Okay? So when I have two vectors, let's say A and B, the sum is the net vector, is equivalent to have A and B going like that. Right? So I can represent these two vectors as one vector. Do you see that? That I can, because it's a sum, right?
Can we just add the vectors?
You can just add the vectors. What I'm trying to say is that this vector C here, that is A plus B, is the same as having them separate, is equivalent. Okay? That's very important to understand. Because if I have, for instance, a body here, or a particle that has force A and force B acting on it, I can add that up and I have a resultant represented by one vector, right? So let's say I have, let's give an example. I have a vector A, and I say vector A is 3I minus 5J. Can you calculate the magnitude of this vector? What is the magnitude of this vector? So the magnitude of this vector is going to be what? So 3 is like having here, this point 3 and negative 5. So it's going to be somewhere here. It doesn't matter at this point. So 3 and 5, right? And I have a, this is 3, and this is negative 5. So I want to know this here, right? So what is the value of this distance here? What is the theorem that you're going to use? Yeah, it starts with P. What is the theorem? Yeah, so so is this going to be square root of 3 squared, 9, plus negative 5 squared is 25. So it's going to be square root of 34. That is the new magnitude of that vector. Is that fine too? No? Is that
Would
okay?
it be 4, which would be 25 minus 9? Or
25 minus?
Yeah.
No, because C, it's A squared plus B squared plus C squared.
This is square.
So it's 9 plus 25.
Is that okay? So this is addition of vectors. Remember, we covered 2 multiplication of vectors, right? 2 different products of vectors. One is called the dot product, right? The dot product. And the other one is the cross product. So we represent A dot B, and here we represent A cross B. 2 different things. The definition of the dot product is going to be the module or the magnitude of A times the magnitude of B times the cosine of it. Okay? Cosine of it. So if the sine is 0, how do I calculate the dot product? If the sine, if the angle is 0, what is the cosine of 0? 1. So the dot product is going to be just the product of the 2 magnitudes, right? If the angle is 90, what's going to be the product of A and B? Huh? 0, right? Okay, so let's go now the an example of this here, and this is a scalar, okay? Comes up to be a scalar. So that if I have the product of force times the displacement, this product is going to be work, and work is not a vector, okay? So when we have quantities that when we calculate the product and the product does not result on a vector, we use the dot product. That's different. Some quantities, when we multiply, they result in another vector, then we have to use this product. Okay? Like torque, for instance. Right? Distance times force gives you a torque, and the torque has a direction. Could be up or could be down, depending on the direction of the force. So here, the dot product is going to be the module of A times the module of B times the sine of that. Okay? So we're not going to use this immediately, but I'm just putting down here so you start thinking about this. So when it comes the time you know. Now, how do you know if this is going up or going down? For instance, if I have a vector A this way and then B this way, is the new vector, the product, going inside or coming out? How do you know that? Well, there is a rule. It's called, we can call this the right-hand rule, or you can call the potato cork rule. So if I'm moving this way from A, because it's A times B, if I move this way, my thumb is going in, so the new vector is going in. Or you can call this the cork, potato, right? When you get this cork, you know the cork for wine? You guys drink wine? No. So when you try to rotate that, what's that called? The thing? Yeah, I don't drink wine, so I don't know these things. So when you rotate this way, right, it goes in, right? So if I'm rotating this way, it's going in. If I rotate the opposite way, right, if it's B cross multiply A, right, then it's this way. So my thumb is going out, and I'm,
Wait, is that B times A or is that A times A?
this is, I'm sorry, this is B, okay? B times A, right? Then goes the opposite way. So what does that mean? That means that A times B is equal negative B times A. All right? So this is going to be very useful when we start studying torques. Is that okay? So now let's talk a little bit about interpreting graphs. That's another very important topic. That I hope today, with today's experiment, is going to become easier for you to understand. Interpretation of graphs. So, on the first experiment, well, let's just say I have here, this is X, this is my Y axis, and here I have a line, and then I have point X1, point X2, Y1, and Y2, okay? So this line is going to change its angle, and we need a way to measure that, right? How fast is Y changing per unit of X? That is called the slope. So the formula for the slope is Y2, Y1, X2, X1. Right? That is the slope. When I make this here equal to 1, X2 minus x1 equals to 1. So I have the rate of change in 1, okay? If this is 1, this height is the rate of change. And because this line is a straight line, that rate of change is constant. Is that okay? This has to be really clear. So now let's do an example here and see if you guys understand what's going on. Each one of these intervals. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And this is 1, 2, 3. So let's say I have one point here. This goes from the origin to this point. And then here I have 1, 2, 3. And goes up to here. So let's see. So this is x, and this is y. So what's happening here? What's happened to the rate of change here?
Decreasing.
It's decreasing. Well, it's positive or negative?
Negative.
Negative, okay? So the rate of here is decreasing and is negative, right? What about here?
It's increasing.
It's increasing, right? What about here?
It's not.
The slope here is
Non-existent. Zero.
0. The slope here is 0, right? The slope here is positive. The slope here is negative. What about here?
Negative.
Negative. Here?
Zero.
0 and 0. Okay? All right, so now let's go to the equations of motion, right? That the first experiment that we did, we derived some equations from there, so let's review that. And another thing for quiz Tuesday, you should start preparing your table with all the formulas. I'm not going to put down the formulas on the quiz. You need to bring your own paper with all the formulas that you're going to need, okay? So the experiment we had, the first experiment, we had time here and distance, okay? And then we had here some x0 here. And then here I have x. And then we calculate this slope here. What was this slope? What is the slope of this line, if I give you these 2 points?
The slope is x1 minus x0 over 2 minus 2, 0.
So m, the rate of change, right here, we call that average speed now, right? We're going to call the average speed v average. I can write that way, or I can write v with a bar on top. That means, a bar means average. It's different than I write v with an arrow, okay? V with an arrow is a vector. V with a bar is the average, all right? So this is going to be this delta x here, I call this delta x, that is x minus x0, and the delta t here. D, delta t, right? But t0 is 0. So it's going to be x minus x0 t. Okay? So that's the first equation that we came up with. So I can now rewrite for x, right? Is that easy to, can you solve it for x here? What do I do to solve for this for x? Solve it for x. I want to have an equation with x equals to something. What do I do? First, I multiply by t on both sides of the equation, right? Okay? So I'm going to multiply by t on both sides, so I'm going to have v bar times t equals x minus x0. Okay? And then I isolate x here. I'm going to have x by itself equals x0 plus v bar t. So that's my first equation. All right? Is that okay? Now, the average speed, so this is the average speed, right? The average speed can also be calculated a little different, right? What would be the other formula for the average speed? The average speed is v0 plus v divided by 2. Okay? Is that okay? So this is the formula for the average speed. Yes?
I have a question. So for average speed, is it just a bar on top or an arrow on top?
The arrow